In this module, you will learn about the number of atoms in a unit cell. You already know that every crystal lattice is made of an infinite number of unit cells, and every lattice site is occupied by a constituent particle that may be an atom, an ion, or a molecule. Now let's examine what portion of each particle belongs to a particular unit cell. Consider three types of cubic unit cells. For the sake of simplicity, assume that the constituent particle is an atom. Let's start with a simple or primitive cubic lattice. A simple cubic lattice consists of 8 atoms at the 8 corners of a cube. In the open structure shown here, the distances between the atoms are greatly exaggerated. In reality, the atoms are packed much more closely together, as shown in the space-filling model here. The space-filling model shows that the atoms touch along the edges of the cell. By considering the portion of atoms inside the cell boundary, we can generate a unit cell of a simple cubic lattice. From this, it is evident that each atom at the corners contributes 1/8 of its original volume to each unit cell. There are 8 atoms at the 8 corners. Thus, the number of atoms in each unit cell is equal to 8 corner atoms into 1/8 of an atom per unit cell, which is equal to 1. A body-centered unit cell contains 8 corner atoms, just like in a simple cubic unit cell. However, there is one more atom at its body center. As a result, the atoms at the corners no longer touch along the edges of the cell in the space-filling model. The unit cell of a body-centered cubic cell is shown here. It is clear that the 8 atoms at the corners contribute 1/8 of their actual volume each. In addition, one atom lies completely inside the cell. Therefore, the number of atoms at the corners per unit cell is equal to 8 corner atoms into 1/8 of an atom per unit cell, which is equal to 1. There is one atom at the center of the cube. Thus, the total number of atoms in a body-centered cubic unit cell is 2. The face-centered cubic lattice consists of 8 corner atoms, just like in the simple and body-centered cubic lattice. However, it also contains 6 more atoms at the 6 faces of the cube cell. The atoms touch along the diagonals, and each touches 4 corner atoms. A unit cell of a face-centered cubic cell is shown here. It is clear that the atoms at the corners contribute 1/8 of their original volume each. In addition, there are 6 atoms at the 6 faces, which contribute half of their original volume each. The number of atoms at the corners per unit cell is equal to 8 corner atoms into 1/8 of an atom per unit cell, which is equal to 1. The number of atoms present at the faces per unit cell is equal to 6 atoms at the faces into half an atom per unit cell, which is equal to 3. Thus, the total number of atoms per face-centered cubic unit cell is 4. You have now reached the end of this module. In this module, you learned that every crystal lattice is made of an infinite number of unit cells, and every lattice site is occupied by a constituent particle. There is one atom in a simple cubic unit cell. There are 2 atoms in a body-centered unit cell. There are 4 atoms in a face-centered unit cell.